Yeah, in trigonometry, we have this topic called uh, all silver teacups to find which ratio is positive in which quadrant. And when we are talking about the submultiple angles like more than 90 degrees, like in up to 10th class or up to secondary school, you might be studying about sine 30, sine 45, sine 60, sine 90, up to 90 degrees. Now, what if they ask you to find sine 120, sine 150, sine 300, or cos 300, tan 250, lot of like this. Then you need to remember the quadrants in which this sine theta, cos theta, and tan theta are positive or negative. So for this purpose, it was mnemonic was developed. It was known as all silver teacups. But how come that's true? But before going to all these topics, let us discuss each step by explaining clearly. Okay. So let us, if you want to find, let me discuss about this quadrants. And here the angles are always measured in anti-clockwise direction, so it will go like this, okay. So now this is quadrant 1, and this is quadrant 2, and this is quadrant 3, and this is quadrant 4. And in quadrant 1, all ratios like sine theta, cos theta, cosecant theta, tan theta, cot theta, secant theta, all are positive. And in second quadrant, only sine and its reciprocal are positive. And in third quadrant, only tan and cot are positive. And in fourth quadrant, cos and its reciprocal secant are positive. So that's why we can remember this uh, particular thing with the help of a mnemonic called as all silver teacups. But why need to remember this thing? Why need to remember this thing? So all silver teacups is not maths. It's just a mnemonic. Okay. Now, why in quadrant 1 all ratios are positive, and why in quadrant 2 only sine theta and its reciprocal cosecant theta is positive, and why in third quadrant tan and its reciprocal cot is positive, and why in fourth quadrant cos and secant are positive? Yeah, we do have a proof of these mnemonic to exactly justify what we are remembering by the help of a mnemonic. We are remembering by the help of a mnemonic all silver teacups. In first quadrant all ratios are positive, and second quadrant sine theta and its reciprocal is positive. And we do have a proof to justify what we are remembering, and now I'm going to tell that proof. Now, yeah, so before going to that, let me write the angles of the corresponding axis here. Though the starting angle starts with 0 degrees here, and here it is 90 degrees, and here it is one more 90 is added to here, so it will be 180, and this will be 270. So in quadrant 1 the angles are always less than 90 and more than 0. So the angles are always less than 90. It will be 90 minus theta, and second quadrant it will be 90 plus theta and 180 minus theta, and third quadrant it will be 180 plus theta and 270 minus theta, and fourth quadrant it will be 270 plus theta and 360 minus theta. So when we are completing a single rotation, that means we are making an angle of 360 degrees. So making an angle of 360 degrees or multiples of 360 means we are coming to the starting point. So these are the uh, like the profile of angle in each quadrant. In first quadrant the angle will be 90 minus theta, and second quadrant it will be more than 90 and less than 180, so it will be in between 90 to 180, in between 90 to 180. And third quadrant it will be between 180 to 270, and fourth quadrant it will be 270 to 360 degrees. First quadrant it will be 0 to 90. Now, as I told you, in first quadrant all ratios are positive, but why all ratios are positive in first quadrant? Okay, now we are going to discuss about that thing. Let us draw this axis Cartesian plane one more time. Now, so this is quadrant 1, and we know that this is positive x-axis and this is positive y-axis, and this is negative x-axis and this is negative y-axis. Now, when we are talking about ratios like trigonometric ratios in first quadrant, okay, we will describe them with the help of a triangle. Now take a triangle here in the first quadrant, because we know that sine theta and all trigonometric ratios are only defined for a right angle triangle. So let us take a triangle here. Now, when we are considering angle like this, this will be the right angle triangle formed. Now, it will be opposite side, and this will be adjacent side, and this will be hypotenuse. Now, the adjacent side will be positive because it is lying on the positive x-axis. It might be +2, it might be +3, or it might be +4. Since it is in the positive direction of x-axis, we know that on the positive x-axis the values will be 0, +1, +2, +3, like this. So definitely this will be positive, and also opposite will also be positive because we are going in the positive direction of y-axis. That means upwards. When we are going vertically upwards, it is positive y-axis direction, so this will also be positive. And when these two are positive, hypotenuse will be positive, because hypotenuse is nothing but the square root of adjacent square plus opposite square, so definitely it will be positive. So now if we consider sine theta is opposite by hypotenuse. We know that from SOHCAHTOA. So sine theta is opposite by hypotenuse. Opposite is positive and hypotenuse is also positive. So positive by positive will be positive. And if sine theta is positive, when we reciprocate it, it will become cos theta, and it cannot be negative, because when we got the number like 2/3, 2/3 is positive. If we do reciprocal of 2/3, it will become 3/2, but it never going to be change the symbol. So if a number is positive, definitely the reciprocal of the number is also positive. So if sine theta is positive, its reciprocal cosecant theta is always positive. In the same way, let us consider cos theta. Cos theta is equal to adjacent by hypotenuse. Adjacent is positive here, because when we are going in the positive x-axis direction, and hypotenuse is always positive. So again, positive by positive is positive, and if cos theta is positive, then its reciprocal secant theta is always positive. And similarly, the same rule exists for tan theta. Tan theta is equal to opposite by adjacent. So positive by positive, that will become positive, and its reciprocal cot theta is also positive. So that's why all the ratios are positive in the first quadrant. So that's why it is remembered with the mnemonic all. Okay, so here A indicates all the ratios, all the trigonometric ratios are positive. In the same way, let us consider one more triangle here in the second quadrant. Now, here we are going in the negative x-axis direction. That means the adjacent side will be negative. The adjacent will be negative, and we are going in the positive direction of y-axis. So that's why it is moving. We are moving in the vertically upward direction. It will be positive, and hypotenuse is always positive, because hypotenuse is given by root of opposite square plus adjacent square. So root of minus something -2 whole square plus 3 whole square. Let us take it as some -2, and let us consider it as some +3. So when we are squaring it, we will get the positive number. So it will be root 13, it will be positive. That means the adjacent is negative and the opposite is positive and the hypotenuse is always positive. So that's why when we consider sine theta is nothing but the ratio of opposite by hypotenuse. So here opposite is positive and hypotenuse is positive, so positive by positive is always positive, and sine theta is positive, therefore cosecant theta is also positive. And similarly, when we consider cos theta in second quadrant, cos is adjacent by hypotenuse, adjacent is negative and hypotenuse is positive, so negative or positive is always negative, because minus 2 by 3 is not equal to 2 by 3, it is always minus 2 by 3, so the entire cos theta will be negative. So if cos theta is negative, then its reciprocal will also be negative, secant theta, so that for secant theta is also negative. And similarly, tan theta is opposite by adjacent, so opposite is positive, adjacent is negative, so tan is also positive. Only sine and its reciprocal cosecant are only positive, remaining all ratios are negative. So that's why we are remembering it as all silver teacups. Similarly, if you do the same kind of explanation for the third quadrant also, you'll get the answer. Here adjacent is negative and also opposite is also negative. Why? Because we are going vertically downwards, so vertically downwards means negative y-axis, so both x is negative and y is negative, and by default hypotenuse is always positive, because hypotenuse is nothing but root of opposite square plus adjacent square. When we are squaring these two, definitely will become positive, so this will become positive. So here tan theta is defined as opposite by adjacent, opposite is negative and adjacent is also negative, so negative by negative it will become positive. So that's why tan theta is positive and its reciprocal cot theta is also positive, whereas remaining all ratios will become negative, because sine theta is opposite by hypotenuse, opposite is negative and hypotenuse is positive, minus by plus is minus, so if sine theta is minus, cosecant theta will be minus. Okay, so it's all about quadrant 3, and the same is the case for quadrant 4, and you can do it and you can tell me which ratios are positive in the fourth quadrant. And this is how the mnemonic came, and the mnemonic existed all silver teacups. And we should not remember the mnemonic as usual by not clearing our doubts or not by justifying this thing. See, mnemonic is okay, but how, why all ratios are positive in quadrant 1 and why sine theta is positive in quadrant 2, and this is the explanation of why sine theta is positive in quadrant 2 and why tan theta is positive in quadrant 3 and why cos theta is positive in quadrant 4. This is the explanation of this mnemonic all silver teacups. So next time you are learning this mnemonic all silver teacups, it's fine, but you need to know the background of this mnemonic or any formula. Unless otherwise you need to know the background, you cannot simply by heart it. So that's how it came, and thank you.